Good morning all of you. In the last class we have discussed about the surface sources of water supply and also completed the two parts of subsurface, two types of subsurface sources, that is infiltration galleries and infiltration well. And today we are going to discuss about the next type, that is springs. So, the natural outflow of groundwater at the earth's surface is said to form a spring. So, a pervious layer sandwiched between two impervious layers gives rise to a natural spring. That means, when suppose this one is a pervious layer which is placed between two impervious layer. So, this one is impervious layer and this one is also an impervious layer. So, when a pervious layer is sandwiched between two impervious layer, that means here this one is confined. This pervious layer is confined between two impervious layer. So, this will gives rise to a natural spring. That means the water will coming out of this pervious layer. Okay. So, these springs are generally capable of supplying very small amount of water and therefore they are not generally regarded as sources of water supplies. However, good developed springs may sometimes be used as water supply sources for small towns. So, now let us discuss about the different types of spring. So, these are of three types. One is gravity spring, second one is surface spring, third one is artesian spring. So, first we will discuss about the gravity springs. So, when the groundwater table, this one is the groundwater table. So, when this groundwater table rises high and water overflows through the sides of a natural valley. So, this one is the valley or depression. So, when groundwater table will rises high and the water flows through the sides of the natural valley, the spring formed is known as your gravity spring. Okay. And the flow from such a spring will vary with the rise or fall of the water table. That means when the water table will go down, so the flow will be get hamper, and when it will rises high, there will be flow of water through to the depression or valley. So, this will depends upon your rise and fall of water table. Okay. So, now we will move to next type of spring, that is surface spring. So, in surface spring, sometimes an impervious obstruction or stratum, sometimes when this one is the impervious layer or impervious obstruction. So, this influence sometimes an impervious obstruction which support the underground storage, this one is the underground storage, becomes inclined, will cause the water table to go up and get exposed to the ground surface. So, for that means sometimes what happen, when this impervious layer will becomes inclined, it will increase the level of the groundwater table, and the water will become will get exposed to the ground surface and will form a spring. So, this type of spring is known as surface spring, and the quantity of water available from such a spring is quite uncertain. Okay. Then we will move to the next type of spring, that is known as your artesian spring. Third type of spring, that is artesian spring. So, here when the water bearing stratum, this is known as your water bearing stratum. When this water bearing stratum is under pressure, that is the water is flowing through some impervious water is flowing through some confined aquifer. That means the aquifer which is confined between two impervious layer, that is known as your confined aquifer. So, when water is flowing through such type of confined aquifer, the spring formed is known as your artesian spring, and this type of spring are able to provide almost uniform quantity of water. Okay. So, in case of a spring, when the water flows out of the ground, a lake or a pond gets formed. So, a pakka masonry wall will is to be constructed on four sides of this pond. We have to we have to construct a masonry wall on four sides of the pond, which is formed due to the water. So, this masonry wall should be covered at the top in order to prevent it from any type of contamination. And proper cleaning of this area and arrangement for excluding the surface water from entering the spring should be properly made. So, the water collected in this tank or pond can be carried through pipes into the downstream reservoir for supplies. Okay. So, this is all about your springs. Okay. So, this is all about our springs. Then next we will discuss about the next type of subsurface, that is subsurface source, that is wells. So, wells, a water well is a hole, usually vertical and excavated through the earth stratas for lifting groundwater to the surface. So, the wells may be classified into two types. One is open well, second one is tube well. So, first we will discuss about the open well or dog well. So, these are as we know, as we all have seen the open wells. So, these are open masonry wells having a comparatively bigger diameter and are suitable for low discharges. And the diameter of open well generally varies from 2 to 9 meter and its depth is generally 20 meter. The walls of open masonry well are made up of precast concrete rings. So, you must have seen this type of rings are connected with each other in order to get the wall of the open well, and they can also be made up of bricks, and the thickness of the wall is between 0.5 to 0.75 meter. Okay. So, the yield of an open well is limited because such wells can be excavated only to a limited depth where the groundwater storage is also limited. Now, these open wells may be classified into two types. One is shallow open well, second one is deep open well. Okay, see, this one is the image of a shallow open well and deep open well. So, this one is the shallow open well, this one is the deep open well. So, shallow open well you can see is the one which rests in the pervious strata. So, this one is the pervious strata and draws its supplies from the surrounding material. Okay. On the other hand, you can see a deep open well is the one which rests on an impervious layer. This one is the impervious layer. Okay. This one is the impervious layer which is called mota layer, and this deep open well draws its supply from the pervious formation laying below the mota layer. So, below the mota layer there is also a pervious layer. So, deep open well will get its supply from the pervious stratum which is laying below the mota layer through a bore hole. So, this one is the bore hole. So, by creating a bore hole in the mota layer. So, this mota layer is a layer of clay, cemented sand or other hard material, and the main advantage of this mota layer is that it will give a structural support to the well resting on its surface. And in case of shallow open well, as it will draws water from the top water bearing strata. This is the topmost water bearing stratum from where shallow well gets its supplies. So, this is liable to be contaminated by the rainwater. So, there are chances that rainwater can be mixed with this pervious stratum. So, but on the other hand, the water in a deep open well is not liable to be contaminated because there is a presence of impervious layer. Secondly, in case of deep open well, we will get larger supplies and larger discharge obtained from the deep open well as compared to shallow open well. Okay. So, this is all about the well. Then next one is we will discuss about the cavity formation in open well. So, what is cavity formation? So, see, this one is a picture of a well. So, for example, let us consider a well from which no water is being withdrawn. Okay. So, for example, if there is a well from which no water is withdrawn, then the water level in such a well, so in the water level in such a well will be same as the static water table outside the well. That means from here there is no water is withdrawn. But now if a discharge is withdrawn from this well, for example, if we will take out some discharge from this well, so what happen? The level in the well will go down. So this is the initial position of the, this one is the initial position of the water level in the well, and this one is the final level. So here the level of the well will go down and stabilize at a lower level than that of the outside water table. So this one is the outside water table and this is the final water level in the well. So this head difference, this difference in level is known as your depression head. So this difference is known as your depression head. So under the influence of this head difference, so due to this head difference, water enters the well from outside. So what happened? I will show you. Okay. So due to this head difference, the water from the outside area enter the well. Okay, you can see here water will flow from the outside in order to fill the gap created by the discharge water. So as the water from the surrounding soil travel towards the well, there is a gradual loss of head and water surface drops towards the well. Hence, the water surface, you can see, will fall gently in the beginning. So this one is the static water table, that means ground water table. So due to this travel of water, there is a the water surface will fall gently in the beginning. So here this one is the beginning. So see, in the beginning there is a gentle fall, but there it will fall more rapidly when it approaches the well. So surface water table surrounding the well will take a curved shape. So you can see here the groundwater table will take a curved shape, and this curved shape is known as cone of depression. This is known as your cone of depression. Okay, and at a certain distance from the well, there is no appreciable depression of water table. And for example, this is the center of the well, and from the center of the well, the point where there is no depression of the water table is called radius of influence of the well. This is known as your radius of influence. Okay, this is called radius of influence of the well. So this is all about your cavity formation in open well. Okay, so in the next class we will discuss about the tube wells. Thank you.